Hello, sixth grade scientists. Welcome back to science class. Yesterday, um, if you haven't watched the video from the lab from Wednesday, you should probably go back and watch that because this will make a lot more sense if you do that. Those of you who have, go ahead and open your science journal, wherever you wrote down your hypothesis and our data from yesterday. So just remember that we are trying to see how does the dew point change with different air masses. And we had three options. One option was doesn't matter. Dew point, all right, is going to be the same between two very different air masses, or one dew point is going to be a lot higher, or the other one's going to be higher. So those are kind of your three options. So you're going to make a prediction about if outside or inside was going to have a higher dew point. All right, this is our data from yesterday. I've highlighted the most important part. Where our temperature started really doesn't matter. That's just to make sure that we are having our constants and our control and the same amount of water as well. What we were looking for is what temperature did the condensation show up? Remember, outside 3 degrees Celsius, inside 14 degrees Celsius. All right, and just to give you a reference point, room temperature is like 23 to 24, 25 degrees Celsius typically. For us, that'd be in the high 60s, low 70s in Fahrenheit. All right, so what we need now is let's put this in a graph. Let's put this in a graph it helps us understand what's happening. So take a look at this here, and what you have written down, and think about. I wonder what type of graph would be most appropriate. Here. All right, so go ahead and think about that for a second. We can have a line graph, we could have a bar graph, or we could have a circle graph are the three most popular choices typically. All right. So if you said bar graph, you're correct because we're just comparing totals, right? We're just going to compare the difference right here, right? Different air masses. And so we're going to have a single because we just have one set of data that we are going to be graphing. So you can go ahead and write this down if you want, or you can just kind of follow along. So we have a graph paper, and I've set up a graph here. And so we've already had our labels, right? So, what are we looking at here? Well, this is our title. So what are we looking at? Dew point measurement inside and outside, right? Right here. And this is a measurement, not a calculation, because we actually took data down. So remember, to find these numbers, we're going to look back up at our data and try to look for, there it is, try to look for what numbers do we need to actually show. All right. So if you look right here, we're graphing 3 degrees Celsius and 14 degrees Celsius. All right, so that is a range of 9, and that shows our low value to our high value. Our low value is so low, close to 0. We'll just leave 0 as it is. And then our high is going to be 15 or 14, and we're going to go just above. That way our graph doesn't run to the top. All right, and then this is where we have our inside and outside. And this is our graph. It's the same exact information, just helps us to understand and see it a little better here as well. All right, so we have our data. Now we have to figure out what do we actually learn from this. All right, okay, the inside dew point was 14, the outside was 3. Okay, so what does that have to do with anything? Is this a fun activity, right? You can do and calculate it, or is there something more important going on? And that's the truth. All right, there is. All right, we are trying to understand, all right, what is dew point and how can we calculate it, and do different types of air have different types of dew point ranges and what that actually means. All right, so we're going to go ahead back to our dew point here real quick, and just to a sense to see, okay, what's actually happening. right? The condensation is happening on the outside of the cup, like Mr. Gladwell talked to you guys about earlier in the week. So why is it? The dew point, at the dew point and below the dew point, water vapor in the atmosphere will condense on anything touching the atmosphere. Could be a cup, could be a car, could be a piece of grass, could be a spider web. If it's up in the upper atmosphere, it could be a piece of dust. We're talking about condensation in the water cycle. And so right here we have condensation on the outside. So what's the temperature of the cup? Think about that. Right? It's got to be at or below the dew point. Right? You have colder water inside here. It cooled the glass down. All right, which cooled the air right around the glass down, and all that water then condensed. All right. So now we got to figure out what's actually happening here. So when we finish a experiment, we do a conclusion or analysis to try and figure, okay, what happened? Did we actually see different dew points happening in different air masses? What was the actual answer to our research question, which was, how does dew point change between two different air masses? All right, so we always start this with, first off, was our hypothesis correct? So go back to your data real quick here. You can pause it if you want to take a look at it and look at, what did you put for your hypothesis? What did you think was going to happen? Did you think that the dew points would be the same? Did you think that the inside would be higher or the outside would be higher? All right, so I started with mine, and I didn't write mine down here, but I'm going to tell you what I thought was going to happen. And this is one thing I love about science class. You never know what's going to happen. Typically, we do this experiment at school, inside and outside, during the school day. And last year when I did this, it was a really hot, muggy day. And so I expected that the inside was a much lower dew point and the outside was much higher, which is the case, but it wasn't the case here. So I wrote my hypothesis was incorrect because I predicted that the dew point outside would be higher than the dew point inside the house. It's just to reflect over, what did you think was going to happen? You may write this down in your journal if you want. However, you do not need to. If you think it's going to help you understand this better, go for it. But there's nothing you're going to need to turn in. So just kind of work through this conclusion with me as we do it here together. All right. The second thing we look for is, what did we actually learn? Right? What did we actually learn from this? And so we're just going to answer the question: how does a dew point change between two different air masses? And we're going to have evidence from our data as well. So we'll start here with our first sentence. Is that, what did we learn? We learned that the dew points in the two different air masses have different dew points. All right, they have different characteristics if they're different air masses, and they are different. And we know this because, I might have issues with this. I'm not going to do the whole thing right now just so I don't look silly in front of this camera any longer. All right, we'll stop it right there. Let's see if we can't get it bold. No, we'll do it this way. All right, so we learned that the different air masses have different dew points because our data tells us that these two different groups of air, one inside, one outside, even though they were close together and looked the same, right? However, the dew points were drastically different. All right, the dew point was only 3 degrees Celsius, while the dew point inside the house was 14 degrees. Again, go back to our data. All right, our data helps us explain what's happening. All right, and then we're going to explain a little bit about it. So the dew point was higher in the house because the air in the house had more water vapor in it than air outside the house. So this is just our explanation of why do we think this may have happened. Higher the dew point, all right, means that there's more water, more water in the air. So why did this happen? Well, I was thinking about something we went over last week. And if we look at this graph about where our air masses are coming from, we had a cold front come in with thunderstorms and our colder temperatures. And typically our cold front air is going to come from this region right here, most of the time because of where we are in the United States. And this is going to be colder, drier air. And so it's been a little chilly outside. You might have also noticed that it just doesn't feel, when it warms up, it's still got a chill in the air. It's dry, right? There's less moisture in the air because this air mass has just been sitting over land and hasn't had any way to really pick up a whole lot of moisture through evaporation. And this is one reason why the outside air is going to have a lower dew point than the inside air. All right, the inside air has been stuck inside. We've got insulation in the house, we've got a roof, we got walls, we got windows that are meant to stop energy and moisture from moving back and forth. Haven't been running my air conditioner because it's been chilly, so that all that water in the air is just stuck, right? I mentioned yesterday too that I did this near my kitchen where we boiled water for dinner and the dishwasher's running and hot water, the coffee maker and hot pot and all those things are just putting a lot more of, without the air conditioner pulling the air out, the air mass, the air inside of the house has had a lot more water than the outside of the house. All right. So we need to do when doing our conclusion. Our conclusion is try to figure out, was there something that might have made our data not do what we thought it was going to do. So one possible source of error I thought about was, if you notice in the video, I couldn't see the thermometer. It wasn't tall enough to get above the cup without the thermometer being out of the water. Because once you pull the thermometer out of the water, you're going to start getting the temperature of the air. So if you notice, I had to kind of tip it. And so that might have been something that might have thrown our data off a little bit. All right, as well. It's not that necessarily I did anything wrong. It's just as scientists always want to make sure it could have been something else. All right, that was happening. We always finish science experiments with questions. So one question I have, well, actually, why don't you go ahead and think about that for a second? After doing this experiment, what questions do you have? What questions do you have about dew point? What questions do you have about why the dew point was different, how we calculated it? If you want to pause it and think about that for a second, you write that down if you wanted, just to help you. If that helps you just think it through. So my question was, we had that cold front come through. I wonder what the dew point was before that cold front. So I wonder what the dew point was in Benton or around here, like on Saturday or Friday. I wonder if that dew point was, 14 degrees Celsius or higher. I wonder what it could have been as well. All right, and that is our lab write-up, our lab conclusion, and answering how does the dew point change between air masses. All right, it is changing. It's changing because they're different air masses come from different places, and they have different characteristics, right? Just like, different people have different characteristics, different food have different tastes, different air masses have different dew points, which means different amounts of water, all right? Different amounts of humidity in the air, just like Mr. Gladwell talked to you about later in the week. Hey, awesome job. Thanks for going through this. And again, if you want to do this at home, please do. Try it out. Test it out and see if you get something similar to me or not as similar to me if you have the materials. Tomorrow we're going to take a little bit of time to talk a little more deeper about dew point and what it actually means and why it actually happens. And then we'll have a couple questions to answer for understanding everything about dew point and humidity. All right, so awesome job. Keep up asking good questions. If you want, you could maybe where your teacher posts this video, under comments, throw some questions down there if you have about dew point. Maybe you can see what some other questions the other students in class might have as well. So awesome job. Stay safe. Wash your hands. All right, and we will see you tomorrow.